As many of you know, there's an ongoing worldwide issue of how straws are killing turtles and are ruining the environment. We all have heard about those reusable straws or paper straws, but what about all the plastic straws we have left and continue to use each and every day? We want to help the ocean and the sea turtles. Now, however, we cannot solve the problem of straws and plastic in the ocean, but we can help it. For our project, we have designed a prototype that will cut down a straw into smaller pieces. These smaller pieces may be easier to break down and not cause as much damage to the sea turtles. This is a video representation of how our prototype works. As you can see, you manually feed the straw through the scissors with your hands. You can also see that every time the scissors open and close, they do not cut the straw completely every single time. However, the scissors do cut a little slit in the straw, which will in turn make it easier to break down in the end.
The simple sweeper function of the servo library was used to power the servo. However, it was modified to move to and from certain positions so that the scissors would open and close according to how we needed them to. Its initial position of the arm and the position interval was also changed so that the servo arm would move in intervals of 2 degrees rather than 1, thus increasing the speed of the servo. The loop section of the code allows the servo to spin continuously, for the initial position being 5 degrees, for whenever the position is less than or equal to 90 degrees, the position will increase by 2 degrees in the positive direction. The servo is given 15 milliseconds to get to that position. The same is true for the second part. If the initial position is 90 degrees, for whenever the position is greater than or equal to 5 degrees, the position will decrease by 2 degrees. It again allows 15 milliseconds for the servo to reach that position. This button is connected to the power for the servo motor. When the button is pushed, the power for the servo motor is turned on, thus spinning the servo motor. This contraption allows the servo motor to spin, opening and closing the scissors. This slit up here guides the straw directly through the scissors, as well as holds it in place.
When we first started this project, we ordered a stepper motor with an A4988 stepper motor driver. However, when we finally got the motor to spin without any switchbacks, we determined that there wasn't going to be enough torque in order to open and close the scissors. Therefore, we decided to order this new stepper motor that could handle more torque. For testing, we had to determine the angle at which the scissors would open and close best, and after testing we determined that 5 degrees and 90 degrees were the two angles that it would rotate in between. As we fed the straw through the scissors, we wanted to determine the smallest range of motion in order to cut the straw. We also had to experiment with many different types of ways to connect the servo motor into the scissors. We had experimented with a couple other parts, however the two metal plates worked best.
In future iterations, we would like to have more panels with more pairs of scissors. We would have one here and then another one behind here. On each panel there would be 2 sets of scissors and also a servo motor. The reason this would be in the future is because we would need more servo motors and more time to put all of it together. Another thing we could do is capture the straw shavings, which could then be repurposed in the future. We could also add a motor, such as a DC motor on the top here, that would roll the straw through the scissors.